Search for pyramid mysteries online, and you enter a digital ecosystem that generates billions of views. Across global platforms and massive markets like Hindi media, the algorithms are flooded with theories attempting to explain who really built them. The core tension driving this obsession is geographical. Cultures separated by thousands of miles and deep oceans all decided to build massive, tapering structures, like the geometric steps of El Castillo in Mexico. This recurring shape appears halfway across the world in monumental Indian temple architecture, like the tiered stone of the Brihadisvara temple. These visual similarities frequently fuel ancient alien theories online. These Bronze Age societies lacked cranes, steel cables, or combustion engines. Moving and stacking millions of multi-ton stones with precision looks impossible when viewed through a modern mechanical lens. Looking past the supernatural claims reveals a physical record of human history and engineering capability that we can still trace in the sand today. A common misconception is that the Great Pyramid at Giza was a sudden, flawless creation, a monument without any historical predecessors. The architectural record documents decades of experimentation. Earlier generations started with flat mud brick tombs and eventually stacked them to create rough tiered layers, like the blocks of the step pyramid of Djoser. When builders first attempted to transition from those rough steps to smooth-sided, steeply angled monuments, they faced significant structural failures. The profile of the bent pyramid provides a physical record of a mid-construction crisis. The original lower angle was too steep, threatening to collapse the entire monument and forcing the architects to abruptly shallow the slope halfway up. These pyramids are the result of decades of physical trial and error by human engineers, rather than a sudden arrival of inexplicable knowledge. The sheer physical scale is difficult to process until you see the individual blocks. A single limestone block often weighs upwards of 2.5 tons, standing as tall as a person's chest. For centuries, it was assumed that this required millions of enslaved people working under duress. Excavations at the base of the pyramids uncovered the extensive ruins of a highly structured worker village. Animal bones and bakery facilities found here prove this was a skilled, well-fed, and organized citizen workforce. Feeding the workers was only half the equation. The project also required moving thousands of tons of high-quality limestone from distant quarries down the Nile River. This fragmented papyrus scroll, known as the Diary of Merer, provides the documentary evidence for these shipments. It consists of administrative hieroglyphic logs detailing the massive stone deliveries arriving by boat. The builders utilized a rigorous bureaucratic administrative system, coordinating labor and resources with a complexity that mirrors modern global supply chains. Once the stones left the boats, they were dragged across miles of desert sand to the construction site without the use of wheels. Archaeologists discovered that workers poured specific amounts of water on the sand directly in front of their transport sledges. On dry sand, material piles up at the front, creating immense resistance. Adding the correct ratio of water forms capillary bridges between grains. This binds the sand layer and flattens the friction curve, dropping the pulling force by 50%. These pragmatic applications of physics and friction demonstrate that mystical theories like acoustic levitation are unnecessary. Strip away the layers of internet myth and supernatural fiction, and the Great Pyramid reveals itself as a physical record of human effort. The components of this achievement were simple: copper tools, woven rope, water, and social unity. These structures endure as a 4,500-year-old mirror. They reflect exactly what a society is capable of achieving when entirely unified behind a single